So this question is about Chloe, and Chloe is riding a bicycle. So let's see. And yeah, in the first part, she got a nail in her front wheel. The radius of the wheel is 30. So that's the wheel that they are referring to, is the wheel of her bicycle. Work out the distance that Chloe travels in one full rotation, revolution or rotation of the wheel. Give your answer correct to the nearest millimeter. So this idea is that if I have a wheel or a circle, right, and now I travel with that, so this circle, now can we make it move? No, I was trying to see if I can make it actually move. I can only move it like that. I cannot rotate. Or can we? Yeah, but it rotates in one place. But we get the idea that basically that circumference, that part of the wheel will just basically cover a specific distance. Now, the idea here is that that length, which is the circumference, when it is spread, is translated into a distance, isn't it, that it covers. Okay, so here we have to calculate that distance that she traveled. Basically, we have to calculate circumference of the circle. And how do we do that? We go to our table, we find the formula where is circle in the beginning of our table. There it is. Here we have the length of the circle, the circumference, and it is 2 pi r. So that length equal 2 multiplied by pi multiplied by radius. So that means in our case is 2 multiplied by pi, and the radius we are given is 30 centimeters. Now don't forget to the nearest millimeter. So we put that in the calculator. What we're going to get is 188.495556 centimeters, right? So if I am to give my answer to the nearest millimeter, how do I change centimeters into millimeters? Well, 1 centimeter is 10 millimeters. So that means that we are going to move that decimal 2 places here. So that will be 1884. And because I'm cutting off 5, so actually that's going to make it 50, isn't it? So that's how many millimeters that is. Okay, let's have a look at next part. So using your answer to part C1, what is that answer? The distance she traveled. I know the circumference, I understand the distance she traveled, one full rotation of the wheel. And the period of ht. Now, this was the function we were looking at in the previous part. The period was that rotation of one wheel takes 0.4 of a second. So that's how long it takes for a wheel to move from the beginning to the end. We have to work out the speed that Chloe is cycling at. So distance, speed, and time, that's what it is, distance, speed, and time. Formula here, so we are looking at speed, so that means that will be distance divided by time. Now, one thing that we have to be aware of here is the measurement. So let's consider again the distance she's traveling is 1885. That is millimeters. Or if I was to change into centimeters, 188.5 centimeters, isn't it? And then the time it takes her is 0.4 of a second. Now, our answer cannot be centimeters by second, has to be kilometers per hour. So I need to change this to kilometers, and I need to change that to hours. So how do we do that type of conversion? That's what I'm saying in this formula. That's what we have to watch out for. So we know that 1 kilometer is what? 1,000 meters. And then 1 meter is where did I get that? Is what? 100 centimeters. So that means I need to change my 188.5 centimeters into kilometers. So how do we do that? So we are saying on one side 188.5 centimeters. We want to know how many kilometers is that. When we know that 1 kilometer is how many? 1,000 meters by 100 centimeters, isn't it? So that's how many centimeters I have in 1 kilometer. And what do? We cross multiply it. So 188.5 multiplied by 1, which is just 1. And then x multiplied by our number here. And of course, we want the value of x, not x multiplied by a number. So what do? We divide both sides of equation. Now, I know that conversion can be figured out in a lot of ways, and whatever way works for you, that's good. The main idea with conversion is that sometimes we multiply and sometimes we divide. Now, with this method, you don't really have to think, do I divide? Do I multiply here? What? Do I divide by what? You just follow it. The main thing is to compare like with like. Yeah, that's the main idea that we are having here. So now that gives me the measurement in kilometers, which is, when we put that in the calculator, 0.001885 kilometers. And now let's change that seconds into hours. So again, we are saying, what do I know? Is that 1 hour, that is equal to what? 60 minutes. And 1 minute, that is 60 seconds. Isn't it? Okay, so that means that 1 hour will equal what? 60 minutes per 60 seconds. That's how many seconds we have in an hour. And then we are saying we need to change 0.4 to x hours. And again, like with like. And again, we cross multiply it. So x multiplied by 60 by 60. And then 1 by 0.4. So that's 0.4. And we divide both sides. Oh, what happened here? That should be 60. I don't know what was that, by 60 and 60 by 60. We put that in the calculator and we get that that is 0.000111 of an hour. Okay, let's solve that in here. 0.000111 of an hour. So now that we have the correct measurement, now we can put that in our calculator, press equal, and we get the answer to the nearest kilometer per hour, 17 kilometers per hour. So that's the speed she is driving with. Like I'm saying, quite a lot of conversion to do, but that's one thing you have to be aware of with distance, speed, and time formula. And the question that has to do with distance, speed, and time could be in paper 2, like it was in paper 2, but they could be in paper 1 as well. It's a kind of traveling topic.